Hi, welcome to the video lecture series on signals and systems. And in this lecture, we are going to be talking about the signal classification. So, myself, Dr. Ganesh Miriyala from the EC department of MLR IT. So, in signal classification, we are going to be see in the next couple of minutes. One is the causal and non-causal signals and anti-causal signals. And then the second category, we are going to be discuss about the even and odd signals, and the third one, it is a random and deterministic signal for this lecture. And the next one, in next lecture, we are going to be discuss about the energy and power signal, and the next one, it is periodic and non-periodic signal. Right, coming to the first one, here we are going to be see the causal and non-causal and anti-causal signals. So, what do you mean by exactly the definition of the causal signal? The causal signal is nothing but for instant time t is equals to 0 and t greater than 0, then the signal is going to be existed. See, for x of t is equals to 0 for t less than 0. That means, if I take any one signal, then the signal at a time t, I am taking, let's see, some x of t, and this is a time value, it is at 0, then this is a plus time and this is a minus time. Okay, so for the negative portion, so the signal x of t is equals to 0 for t less than 0. That means t less than 0, this portion you are going to see the amplitude is 0. That means there is no amplitude for the signal. So let us take one signal I am defining. So this is at a t equals to 3, then amplitude is 1 from there, then the signal is, you can say, u of t minus 3, u of t minus 3. This signal is a causal signal, because for t less than 0, that means this portion is completely 0. So when t is less than 0, then the negative portion value is 0, then we are calling this signal is calling it as a causal signal. Now, for the non-causal signals, then x of t is equals to 0. X of t not equals to 0. Then that is for the some time values t and for some time values t greater than 0. That means you can say I am taking the same representation of the signal at a time t, and the signal name is, here I take it as x1. Now this is a x2 of t and this is a 0 value. So for some time t less than 0, that means, and this position also signal exists, and t greater than 0 and this position also signal exists. So if the signal, any kind of signal exists, the time interval for a negative portion and a positive portion, then that signal is known as a non-causal signal. So if I take the same signal, I am taking its a left shift version, that is minus 3. Then this signal we can represent as x of t plus 3. X of t plus 3, you can solve it since it is a u of t function, then u of t plus 3. U of t plus 3 is a function, you can say non-causal signal. Why we are calling it as a non-causal? So it is a for time t x of t not equals to 0, x of t not equals to 0 for case 1, if it is t greater than 0 and t less than 0. That means it is including two times, this one time and this time also. So these kind of signals we are calling it as a non-causal signals. Now coming to the anti-causal signals. Anti-causal signals means which is completely opposite to the causal signals. So this is opposite to the causal signals. First of all, here we are taking it as a x of t less than 0. So x of t less than 0, that means which includes a 0 also. You can take it as a 0 also. Then where comes to here, x of t equals to 0 for t greater than or equals to 0. That means in the same signal, if I take the same signal at a time t, if I take the same signal at time t, x of t is equals to 0. X of t equals to 0 for t greater than or equals to 0. This is a t greater than 0, and this is a t is equals to 0, and this is a t less than 0. So in these three cases, now the signal is exist. That means t value x of t equals to 0 for this one. That means at t is equals to 0, there it is also 0, and t greater than or equals to, t greater than or equals to 0. That means this entire value is 0. That means where the signal exists, actually the signal is exist for the negative signal only. That means if you take this one for t is equals to minus 3, let us take this as a t value, that is u of t only, sorry, x of t, then x of t you can take it as a u minus u of t plus 3. I'm multiplying minus. So these are the three signal classifications. One is t x of t equals to 0, one is x of t equals to 0 for t less than 0. This is the first case. That means I am giving the example. That means two cases. You can take it as a for the greater than and greater than or equals to also. So this is for the causal, and non-causal you can include negative also, and for the anti-causal you can include only negative. Okay, here it is 0, t equals to 0 and t greater than 0. In these two cases signal exist. Here it is t equals to 0, sorry, t equals to minus, you can call t less than 0, t equals to 0, t greater than 0. Three cases exist. Here only t less than 0 will be exist. This is the main difference among the causal and non-causal and anti-causal signals. So next one we are going to be discuss about the even and odd signals. What is mean by even and odd signals? Suppose if x of t is a signal, and if x of t is a signal and I am time reversing it, or you can call it so where t tends to minus t. Wherever you will find in a signal x of t, you just replace the t by minus t, then that is called the reversal. And we are already studied in the time reversal concept in the signal classification. So signal operations, t tending to the minus t means the signal is reversed in time domain. Then you can say when t is replaced by minus t, in these two cases if the amplitude of the particular signal is same, then that is called the even signal. So when x of t is equals to x of minus t, then the signal is known as even signal. And second one, if x of t, if I replaced x of t by minus t, then if the amplitude is minus, then you will get it as a odd signal. Understood? So two cases. One is if you replace in these two cases we are just replacing t by minus t only. For both the cases we are replacing the signal, t by minus t only. In one case we are getting it as one case we are getting the same amplitude for the x of t and x of minus t, whereas in odd signal you are getting x of t amplitude is multiplied by minus 1 with a x of minus t signals. So this is called the even and odd signal definitions generally. Now see, suppose if I take one signal, x of t is my signal, and in this signal you will have the two components. One is a x e means even signal, x e of t, and second one is x o, that means odd of t. X of t is nothing but it's a sum of even and odd signals, we can represent like that. So in this case if I given one signal, and just I want to ask the question like you find the even and odd component of that particular signal, then what we are going to be do? First case, you just find the relation between the original signal in terms of even and odd components. So if I say, when I can say x of t is equals to x of minus t, that is called even signal. And the condition second one is x of t is equals to minus of x of minus t, that is called odd signal. These are the definitions of the even and odd signal, right? So for this one, now I am trying to find even and odd components in terms of x of t. So in this case, I already written x of t equals to xe of t plus xo of t. That means sum of even and odd components. Now I am trying to write x minus of t. X minus of t means you just substitute wherever you find the t, just replace by x minus of t. So in this one, same one, I am writing xe of, wherever I represent the t by minus t, plus next xo of minus t. Xo of minus t. So this is a next one. So as I mentioned, if it is even signal, as I mentioned, it's a sum of even and odd components, then x of t I can write, x of minus t I can write, since it is a even signal, then xe of t I can write it as. It is a even signal, xe of t. Now xo of t means it is a odd signal. Odd signal means you will get the minus symbol, so that you will get the minus of xo of t. And take this is the equation number 1 and equation number 2. By using these two equations, I can write, add this, do one thing, then plus 1 plus 2, equation number 1 plus 2, which implies x of t plus x of minus t. I mean LHS side I am adding x of minus t, which is equals to this one, xe of t plus xo of t, xe of t plus xo of t. Next one, second portion, this one, plus xe of t minus xo of t. These two are the same amplitudes and the signs are the different signs. So that means you can cancel these two, then you will get the 2 into xe of t. So from this one I can write xe of t is equals to sum of this one, x of t plus x of minus t divided by 2. So this is a one relation. That means if I given some signal x of t, to find its even component, xe of t, and sum of x of t and its reversal character, that means x of minus t divided by 2. So this is about the even signal. Then if I come across the odd signal, 1 minus 2, if you do the same one, x of t minus x of t minus x of minus t, then you will get 2 into xo of t. So from this one you will get xo of t, that means odd signal, you can write x of t plus x of minus t, this one is x of minus t divided by 2. So this is about the odd signals. Understood? So one is even signal, you can represent, now onwards you can represent the any signal x of t, you can find the even component or odd component if you given any signal, then you just do it, x of t and x of minus t, add it and divide it by 2, then you will get the even, divide by 2, before that subtract it, then you will get the odd signals. Okay. The next case, in generally now your academics, you will get the question like prove that product of two even signals and two odd signals is even, one even and one odd is odd. This is generally in your academics they used to ask the question, that is prove that the product of two even signals or two odd signals must be even, and the next one is product of one even and odd signal must be odd. So these are the generally academics based question. So we'll give the solution for this one, though I'm taking it as a case 1, case 2 and case 3. So I'll discuss one by one. The first one, product of two even signals. Let us take x1 of t and x2 of t are two even signals. That means if x1 of t and x2 of t are two even signals, then what is the even signal condition? x1 of t must be equal to x1 of minus t. This is the condition number 1. Then x1 of t is going to be even. Then second one, x2 of t equals to x2 of minus t. If these are the same, then you will get the x1 of t and x2 of t are the even signals. So now what is the question we need to prove? That product of two even signals, I am taking it as x1 of t, one is even signal, product x2 of t is one is even signal. I can write x1 of minus t into x1 of, sorry, not x1, it is x2 of minus t. So since we already know that x1 of minus t means which equals to x1 of t only, then this is x2 of t. So if you see here x1 of t and x2 of t, then you will get the x1 of t and x2 of t. Where you started with a minus, or else you can represent this entire signal, you can call it as a some y1 of t, y1 of t which is equals to x1 of t into x2 of t. Wherever minus is there, you replace it as a y1 of minus t. In these two cases, again you will get the same one, x1 of t into x2 of t. That means these two are the y1 of t equals to y1 of minus t. That means these two are signals also, the product of these two signal is a even signal, since there is no negative. Understood? So there is no negative at all. This is a case 1. Now comes to case 2, product of two odd signals. Product of two odd signals, then same x1 of t is one signal. If it is odd, then x1 of minus t is, sorry, x1 of t is equals to, this is minus of x1 of minus t. This is a first one. Similarly, I am taking it as a x2 of t. Then x2 of t, I can write it as a minus of x2 of minus t. If these two conditions are satisfied, then x1 of t and x2 of t both are the odd signals. Now I am multiplying these two signals. That means product of x1 of t multiplied by x2 of t. Then which is nothing but I am multiplying minus into x1 of minus t into next minus of x2 of minus t. So from here this is also minus and this is also minus, minus into minus plus, then again you will get the x1 of minus t into x2 of minus t. So this x1 of minus t and x2 of minus t are the from the earlier one, there is no negative sign at all, so that you will get the even signal only. So you will get the even signal. So this is the case 2. Next one, we will take one even and one odd signal. So in this case, how the product will changes? x1 of t I am taking it as an even signal, so that x1 of t equals to x1 of minus t, and x2 of t I am taking it as a odd signal, then x2 of t is equals to minus of x2 of minus t. If I product these two terms, that is x1 of t into x2 of t, then you will get the x1 of minus t into minus of x2 of minus t. Then I'll get the one additional minus is there, so that minus into x1 of minus t into x2 of minus t. Again you will have the negative sign, that is a odd signal. It is a odd signal. So this is the answer for the previous question which we discussed. It is a prove that the product of two even and two odd signals and is even, and the next one, product of one is even and one is odd signal, then you will get the odd signal. we'll take one example. How, if I given one signal, how you are going to be find the even and odd components of the signal. Let us take one more question it is. For example, to make you understand, x of t is equals to sin t plus cos t plus sin t cos t. So this is a signal which is given, and find its even and odd components. If I ask the question like that, we need to find it as a, first of all, x of minus t. Find it's a x of minus t. X of minus t means wherever you will find the t, then substitute it as a x of minus t. I can write sin of minus t plus cos of minus t plus sin of minus t into cos of minus t. So the same signal I can write sin of minus t means minus sin t plus cos of minus t, it is a cos t. Sin minus t means it is a minus sin t into cos t. This is a x of minus t. Right? Now you will have the x of t and x of minus t. So in these two cases, if someone asks the question to find its even and odd components, then you need to find, earlier we already discussed, xe of t, it is a even component of a signal x of t. Then you can obtain this even component by using the x of t. We already derived, it is x of t plus x of minus t by 2. So from this one I can take 1 by 2 out, and x of t is a sin t plus cos t plus sin t into cos t, the first term. Next one plus this term, I mean x of minus t term. X of minus t means you will directly write it as a minus of, plus sin t minus, first term it is minus sin t plus cos t minus sin t cos t for the second one. So from here minus sin t, plus sin t minus sin t will get cancelled, and these two terms also will get cancelled. You will get it as a 1 by 2 into cos term is there, 2 into cos t. So from here you can write it as a xe of t is equals to 2 will get cancelled, you will get the cos t. So in this process you are going to be find the even components. So for same one, if I take x odd component, x odd of t is equals to x of t minus x of minus t divided by 2. Then if I do this one, then this time these two terms are going to be get cancelled, and this term will be, these two terms will be valid. Those are sin t 1 by 2 into 2 sin t plus 2 sin t cos t, will get it. 2 will be get cancelled. Then odd signal xo of t, you will get it by sin t plus sin t cos t. This is a odd component. So this is the even component. So by using this signal, in this signal, the sum of these three signals, you can say it as a sin t is one signal and cos t is another signal, and sin t cos t is another signal, where x is defined as the sum of these three signals. And now we need to find the even and odd components. Then we are using this procedure to even and odd components. Next one, random and next classification, it is a random and determinate signal. Random means a signal is a random if its behavior cannot be predicted exactly. That means it's a future value, we cannot detect it based on the its future value cannot be detected exactly, because those signals actually it is a random in nature. For example, if you say noise signal in thermal noise or any noise signal in any electronics and communication systems, the noise is generated by the materials itself. That means you can call it as a capacitor, inductor and transistors. Those all things, internal circuitry will generate some noises. So those are the noises we cannot expect the exact values. So that is called the randomness. So that randomness will be considered under as a random signal, and these signal parameters which we need to consider, it is mean and variance and correlations. So these are the factors which we are going to be considered for the random signals. There is no standard format for the mathematical expression of the random signals. See, x of t we can represent it as some a constant, you can say it's a DC plus n of t. This n of t is a noise signal. N of t is a random noise signal. It's a random noise signal. This random noise signal we cannot predict it. What is the exact value for the next moment? So generally thermal noise in resistors, not only in resistors, you can say any electronic devices like transistor and resistor and capacitor and inductor. These are the few materials, few devices which we will regularly finding the thermal noise. So this thermal noise we cannot find exactly. So that's why we do not have the exact mathematical expressions or mathematical representation for the noise signals. You can call it the random signals. So second one, it is a deterministic signal. Deterministic means we can perfectly estimate the future values of that particular signals. So if you are able to find the future value of any signal initially perfectly, then those kind of all signals we can call it as a deterministic signal. So these deterministic signals, or we can represent its proper mathematical equations. So let us see mathematical representation. X of t is equals to some a is a constant, you can call it as amplitude, a cos 2 pi f t plus phi. Based on this function, if you use the f, t and phi, if you substitute these values and this moment also, let us take this entire value. If I evaluated this entire value for 90 degrees or 90 radians or whatever it may be. So if cos 90 at this moment is fixed, whatever it may be, and similarly after 20 minutes also cos 90 is same only. So that means at present and in future values also we can exactly perfectly estimate that values. You can able to perfectly find that values by using the mathematical equations. That is those kind of signals we can call it as a deterministic signal, right? So the same example which I already discussed, it is x of t is equals to phi cos 2 pi 50 t. So you just vary the time t value at t is equals to 10 and at t is equals to 20. So since it is a cos function, your cos function look like this. So at 0, your cos function look like this. See, these are the amplitudes at 0, some this position, this position, this position, this position. When you are at 1 only, 0, at t equals to 0, your amplitude is 1. Just substitute this value t equals to 0, and at this t value, let us take t1, t2 and t3 and t4. These all t values will give the same value because it's absolutely the cos function. This cos function is only predefined. So we know the cos function definition and what are the amplitudes of the signal. At 0 you will get the 1, and again and this location you will get the 1, at this location you will get the 1. That means you have the perfect mathematical expression for the deterministic signal. So what we have discussed today, one is, first one it is a causal and non-causal and anti-causal, and second one we have discussed it is a even and odd signals. Third one, last one we discussed it is a random and deterministic signal. So these are about the what we discussed today. The next topic we will discuss the energy and power signals. Thank you.